Welcome back, everyone. Now we're going to get to the part of statistics that you usually think of as statistics, perhaps. We're going to talk about the measures of central tendency. In other words, what's sort of the middle of the data, in a way, or a typical data item in your data set. The last time we wrapped up graphs and displays, along with the frequency distributions, which are handy. We're going to talk about the central tendency today, and then next up will be how do those data vary and where do they fit in with the whole data set. But for right now, let's talk about the central tendencies. We're going to talk about the mean, median, and mode. In all likelihood, you've heard of all three of those. You may not have heard of the weighted mean, but you might have actually used it because that's how you figure out the GPA. And last of all, we're going to talk about the shape of a distribution: symmetric, beautiful; uniform, another kind of beauty; or skewed. That's interesting too. Now, how do you compare the mean, median, and mode for each one? So let's start out with, what is it? It's a typical or central entry. And let's see, let's get the ink going here. So you're talking about, okay, where are we? Told depend. Okay, now we're going. Okay, a typical item or a central one. Excuse me. So for example, suppose you're looking for a new house and you see a good neighborhood and you think, I wonder if I can afford one in this house, in this neighborhood. What you'd like to know is, what's the typical price in this neighborhood? On the other hand, you might want to know, what is the medium? Excuse me. The price that's in the middle of all of them. It's another measure of central tendency. So mean, median, mode. In fact, you might want to keep them in order. Excuse me. You might want to keep those in mind in that order. But we'll get back to that. So first, let's talk about the mean, because that's the one you're most familiar with, I'm sure. It's what we usually call the average. You add all the items, divide by how many you've got, and you got your average. Now, what is this gibberish? Well, what it is, get the pen going here, right? Okay, there we go. Okay, so what does this mean? First of all, it means this is each individual item of data that you've got. And it's sort of been put in some kind of an order, where you've got first, second, third, fourth, up to the nth data item that you've got. And this just says you're going from the first one to the nth one, might be the 10th or 15th. And this sigma, this Greek letter sigma, capital sigma, by the way, means that you're going to add them all up. Now I've got two means actually. Oh, don't be too disappointed. There isn't too much difference between them. In the population mean, which uses this Greek letter mu to represent, this means you're going to add all the items and divide by how many you've got. That's all there is to it. And that n represents how many you got in the entire population. Now, didn't I tell you this wouldn't be confusing? The sample mean. Well, yes, it has a different name, but the calculation is pretty much the same. You're going to add all the x's, divide by how many are in the sample, and we call it x bar. That's the mean for the sample. Well, how about an example so you get an idea of how this goes? Here are some weights for some adults in pounds. Let's hope it's not kilograms, right? If you know your metric system, this would not be a good idea. But anyway, all joking aside, we've got 7 different weights, and we'd like to know what is the mean weight of those adults. How do you do it? Well, first of all, you add them all up. It gives us 1,810 pounds. Then you'll divide by how many you've got. You've got 7 different weights, divide by that, and your mean is 258.6 pounds. Someone forgot to leave out the pounds. We shall not leave it out. So there's the mean weight. It did put in pounds down here. That's good. Next, we've talked about the mean for a few minutes. The second one is the median. Notice, by the way, mean, median. Notice that those are not actually in alphabetical order. Mean would come first, median would come second, and just as a note here, the mode will be third, and it comes last alphabetically. So this might be a good way of keeping those straight when we come to the actual distributions. Well, for median, the first thing you have to do is get those things in order. Once you get them in order, that's number one job, then you want to find what is in the middle. Which data item is in the middle of all those data? It actually divides it into 2 parts, a lower part and an upper part. If you've got an odd number of entries, let's say there are 5 data items, the median is the one right in the middle. In the case of 5 data items, it would be number 3 in the list. Of course, that's after they're ordered. If it's an even number and you think, oh, there's no one really in the middle, well, you take the 2 middle items and you take the average of them. Very simple. Odd, you just take the, if it's odd number of entries, take the one that's in the middle. If it's an even number of entries, you take the average or mean of the 2 middle ones, the ones that are tied for being in the middle. So how does the median work? Well, let's take those weights again. You've got 7 different weights. What do you have to do first? Put them in order. What's next? Find the one that's in the middle. This is an odd number of items, so you take number 4 out of, or the 4th item in all the 7 entries, and there is your median. And the median weight of this group is 268 pounds. Now, what about even? Let's get an example of that. Well, let's suppose this person who was 285 pounds decided not to be in your study. What's the median weight of the ones that remain? Well, number 1, you have them in order. Right here, you can see they're already in order. What do you do next? You take the 2 that are in the middle. These are in the middle. And take the average of those 2. And there is your median, 251.5 pounds. It is pretty easy. And third, the mode. Last alphabetically, remember that. This is the one you see happens the most often. For example, you're in a subdivision and you see that a lot of the houses are exactly $250,000. Well, if most of them are that price, then that's the mode. Don't make it more confusing. If none of them are repeated, then we have no mode at all. None repeated, no mode. If you have two that have the greatest frequency, there's a tie, then it's called bimodal. Bi as in two modes. Back for a second. If there's more than two, if you have 3 or 4 or 5 with the greatest frequency, all in a tie, then we just don't say there's a mode at all. So how about these weights that we just talked about? What is the mode of those weights? Well, it's the one that happens the most often. Ordering the data is a big help. In fact, you can even do that on the calculator rather easily. If you ask me in class, I'll show you. Basically, you put all your items, let's say you put all your data items in L1. And then what you'll do is you'll sort them. It's called sort A. Sort ascending. You use that function and you say, okay, I want them from smallest to largest. If for some reason you want the other way, then you could use sort D for sort descending. You can get them in the opposite order, but at least you've got them sorted either way. So how do you find the mode? Well, once it's sorted, you can go through the list one time and find out which one happens most often. If you don't have them sorted, then you have to count how many times each one happened and find the one that happens the most. Sorting is a big deal. It's a big help. Since 235 occurs twice, and all the other ones occur only once, that is the mode, 235 pounds. Next, let's use a real example, or not different kind of example. We've got Democrats, Republicans, Independents, and others. Which one is the mode? All you need to do is look at the frequency. Which one has the greatest frequency? The Democrats, of course. 46 as opposed to 34, 39, and 5. It's that easy. The frequency table helps. The frequency distribution. All three measures talk about what is the typical entry of your data set. However, the mean does have an advantage. It takes into account all the entries, every entry. Nothing is left out. However, if you have one that's extreme, let's suppose we go back to that subdivision you're looking at, and you ask for the mean of all those houses. Well, if most of them, let's suppose most of them are about $250,000. Exactly. And suppose there's also one that is very expensive. You won't be buying that one. But that one's going to throw off the mean. It's going to make the mean larger than a real typical data entry. Here's some examples. We've got ages of students in a class. We could do that with ours, really. Notice one nice thing already. These are in order. That's nice. So, mean. How do we do that? Add them all up, divide by how many we've got. We've got 20. We add all those ages up, divide by how many we've got, and the mean age is 23.8 years. How about the mean? We've got them in order, and there are 2 in the middle. This would be the 10th and the 11th. Add those 2 up, divide by 2 to find the mean or average of those, and there's the median, 21.5 years. And what's the mode? Well, look through. They're already sorted. You have to find out which one happens the most times. And 20 happens to be the ones that has the greatest frequency. Notice that there are 3 ways of describing that typical entry, and they're all different. Well, the mean takes everything into account, but that person who's 65 really throws the mean way high compared to the other typical entries of median and mode. The median takes every entry into account and is not affected by that 65-year-old. The mode exists, but notice that if we went back and looked at that again, the mode happens with some of the first ones in the sorted list. That means that it's going to throw things off too. It doesn't seem to be a typical entry. Sometimes making a graph can help you decide which measure is best for the data set. Now, here's something you might want to take special note of. Well, a couple of things. First of all, among the mean, median, and mode, notice that this tails off to the right extremely. The one of these 3, the one furthest to the right will be the mean. The mode is going to be on the other side, and of course the median is in the middle. And that's going to happen regardless of your distribution. The mean is going to be toward the ones that are furthest out, the median's in the middle, and the mode is at the high bar. Okay, weighted mean. You think, oh shucks, I had mean down, and now we have something else called weighted mean? Oh, come on. Well, let's add something here. We're going to put parentheses around x sub I and w sub I. Well, what do they mean? Well, the x sub I is a number in your data set. There might be one of them, 2, 3, 4, 5, and all you need is one of those numbers. The w sub I is the weight, and that's going to tell you how many of those there are in comparison to all the rest. And the way you do this is you take each one of those data items separately, multiply it by how many there are, or the percentage, multiply them together, add up all those products, and then divide by the sum of all the weights. Put dots on those I's. You might think, so what? What about it? Well, weighted mean actually is important because it's how your GPA is averaged out. So let's take an example and see how this works. First of all, you know A's are a premium, and each A would count as 4 points. Each B counts as 3 points, C's for 2, D's for 1, and we don't want to talk about the F's, do we? But they are 0. So what you do is first make a list of the grades, how many credit hours there are for each of those classes, and then you're going to set up a second table, or maybe you can do it in the same one. How many points? Okay, this is A, B, C, D, F. That's what that represents. So this represents C, C, D, A, C, and there's a B. And then for each one, this class, for example, was 3 credit hours. So what you do is you multiply the 2 times the 3, and there's your product for that class. Second, you've got another C. It has 4 credit hours, multiply those, and you've got 8 credit hours. Once you got all these multiplied together, add those together, and you've got a total of 40 points. Once you've got the 40, you divide by how many credit hours you've got. Those are the weights, and that gives you your GPA, grade point average. Now, how do we get the mean of a frequency distribution? Okay, we've got a frequency distribution someone gave us. They didn't actually give us the data. That's a little bit disappointing. So this is how you do that. So you've got a table here, and maybe you've got, in the first column, you've got a class of items that are anywhere from 1 to 5. And then you've got a frequency. How many did we have? Let's suppose we had 7 of those. And then 6 to 10. Let's suppose you had 8 of those. How are you going to do it with all these? You don't even know, of those 7, which ones were 1s, 2s, 3s, 4s, 5s? You don't know. So what's the best thing you can do? Well, you take the average of those two. Add the 1 and the 5. Your average is 3. So you take that 3, multiply it by the 7. So for the first class, you have a 21. For the second class, 16 divided by 2 is an 8. So the midpoint of this one is 8. Multiply that 8 times the frequency of 8, and you get 64. Add those up and divide by how many you've got. And of course, this represents the sum of all the frequencies, which is what this represents. Remember, these x sub i's are the midpoints, and you use the midpoints because you don't know what the actual data items are, and the midpoint is your best guess. So the midpoint for each class times the frequency of the class, multiply those two together, xi. Actually, I guess we could call this x sub I times frequency of that one, sorry. And then we'll add all those up, divide by how many we've got total, and that would be the mean of your frequency distribution. So here's a list of things you need to do in each order. First of all, find the midpoint for each class. You can't multiply until you find the midpoint. Second, add the sum of the products. So you multiply each midpoint times its frequency. Add all those up, and that's what this is. This is the sum of each midpoint times its frequency. Find the sum of the frequencies. That gives you your n. We're talking about a sample because it's small n, by the way. And then divide by that, and you get the mean for this sample. Notice we know it's a sample because this is x bar. X bar is the mean for the sample, and mu is for the population. So here's one we could play with, actually. So someone has been very nice, and they figured out what the midpoints were for us. So all we need to do is multiply the 172.5 times the frequency 3, and there's our first product. Down here we've got 280.5 times the 6, and there's our fourth product. Add all those products together, we have 8,631, which we then must divide by n to get the mean for that frequency distribution. In this case, 287.7. So the mean screen time for those is 287.7. If you missed, we were talking about screen time, don't forget, you can pause these videos. That's one of the beauties of being able to do that. If we're in class, it's a little bit harder to pause the lesson right in the middle. So there's our mean screen time from that sample. Now we're going to talk about shapes and symmetric distribution. If you have any idea what symmetry is, it means, for example, let's take someone's face. If the left-hand side is a mirror of the right-hand side, then you've got symmetry. Well, the same thing is true with distributions. Where's my cursor again? There we go. If the left-hand side of the distribution looks like the mirror image of the right-hand side, then it's a symmetric distribution. The left-hand side is a mirror image of the right-hand side. In other words, if you cut this right down the middle and folded one on the other, it'd be a perfect match. You could glue the two together and have nothing overlapping. Excuse me. Contrast that with the uniform one, which actually is symmetric too. But uniform is different because the frequencies are all exactly the same. That's a uniform distribution. It forms a rectangle. The top is either flat or almost totally flat. That's a uniform distribution. You don't see that too often, but there are situations where you do have uniform distributions. It's symmetric because the right and left are mirror images. Now, the third kind is a skewed distribution. Skewed. Notice there's no U in there. S-K-E-W-E-D. Now, how can you tell which way it's skewed? Look at the picture. There's your eye looking at the picture, and your eye says, we've got some items on the left-hand side that look like someone took a symmetric distribution and dragged one side to the left. Well, if that's the case, then you call it a left distribution because it's pulled toward the left. The skinny side is toward the left. And if you think of it in terms of a number line, you can say it's negatively skewed because it's to the left. If the tail, for example, looks like this, then it's right skewed. It's a right skewed distribution, and it's positively skewed. It's not real difficult, but you have to remember, and you can use left or right, negative, positive, it doesn't make any difference really. And notice down here, you've got the mean, mode, and median. How do you know where they're going to show up? Well, in this one is skewed left. So if we're coming in from the left, or walking in from the left, or running in from the left, the first thing you're going to run into is the mean, because these extreme values pull the mean out from the center. The mean, the median is always in the middle between the three, and the mode is the last. So mean on one side, mode on the other, median in the middle. If you remember, the mean is toward the skewed side. All you have to do is go alphabetically. Mean, median, mode. And that's how you can keep them straight. There's a skewed right distribution. And notice as I come in from the skewed part, there's mean first, median second, mode third. Coming from the skewed side, mean, median, and then mode. Well, folks, we can see that where the mean is, the mode, the median, we're finished with section 2-3. We talked about central tendencies. What's in the middle? What's a typical value? Well, you take care of yourself, keep smiling, and we'll see you in section 2.4.